Hello students, my name is Shashank Shekhar. So we are on the first chapter of the NCERT 11 chemistry. That is some basic concepts of chemistry. So today we will talk about laws of chemical combination. So this way laws were given to explain the chemical reactions, and this law instead being primitive are very helpful in explaining many of these phenomena that occur during reactions. So let us start with this laws. So there are five laws, such laws, okay. The first one was laws of conservation of mass. It was put forward by Antoine Lavoisier, and you must have studied this law when during studying physics. That's laws of conservation of energy. So similar to that, the law is called as law of conservation of mass for a given reaction. So what does this reaction says? So what this reaction says that during a chemical reaction, what happens? The physical properties changes, the chemical properties changes of which of the reactants, but their overall mass remains constant throughout the reaction. So suppose 2 gram of carbon and 2 gram of say oxygen react to give carbon dioxide. Then if the reaction goes to completeness, then we will see that we have 4 gram of carbon dioxide. Means the reactant species if has converted to product totally converted to product, then the initial mass of the reactants means the sum of the initial mass of the reactant will be equals to the mass of the product. If the reaction has not been completed, then also the mass of the leftover reactants, okay, plus the mass of the formed product will be equals to the initial mass that of reactant that we have taken. So it is written that during a chemical reaction, say for combustion reaction, the physical and chemical properties changes, but there is no change in the mass. Now he named this say phenomena as the laws of conservation of mass. If I want to talk in a broad way, then this law will can be more modified. In the present time, it is known as laws of conservation of mass and energy. Means you cannot say that only mass is conserved. It is there is a chance that this mass can be converted into energy, or energy can be converted into mass. Clear? So, for that, we have taken a combined law that is called as laws of conservation of mass, talking about how mass converts to energy and how energy converts to mass. So, that's a different talk. We will talk about it later. Okay. But for now, if we talk about laws of conservation of mass, so it says that during a chemical reaction, we will see physical and chemical changes, but the overall mass will remain same. Clear? We can say it in a different way also that matter cannot be created, neither be destroyed. Next is laws of definite proportion. So it was given by Joseph Prost. What does this law says? So this law says so whenever a compound is formed, say water. So we have H2O as formula of water. So this law says that the concentration or the ratio of concentration of both this oxygen and hydrogen will remain same in a given molecule of water. Clear? So this is the law of definite proportion. So how can we justify it? So for that, say we have formed water. So what? How many molecules of hydrogen are there in water? Two molecules of hydrogen. Sorry, two atoms of hydrogen and one atom of oxygen. Now, whether you take any molecule of say water or take any mass of water, always there will be this ratio. What which ratio? 1 is to 2. That one atom of oxygen for each atom of oxygen there is two atoms of hydrogen. So whether you take it in mass, it will be also same. So if you take, suppose you take 63 grams of, or say you take 64 grams of water, okay, or you take 66 gram of water. Now I'm taking the ratio as x. Let the ratio be x. So therefore, the amount of what hydrogen will oxygen will be x, and the amount of this hydrogen will be 2x. So therefore x plus 2x is equals to 66. That would give us x is equals to 33. Sorry, 22. Okay. So in 66 gram of water, there will be 22 grams of oxygen and 44 gram of hydrogen. So that is fixed, right? So this ratio, that is 1 is to 2, is fixed. Clear? Now he named this thing as laws of definite proportion, and it is confirmed by various experiments. So you can take this water from any part of the world. Instead, still it will contain 2 atoms of hydrogen and 1 atom of oxygen. So that is fixed. Next one was laws of multiple proportion, and this law was given by Dalton. What does this law says? So this law says that suppose we know that water is formed from the combination of hydrogen and oxygen. We know that because the constituent atoms are hydrogen and oxygen. Now one more thing is true, that another compound can be formed from the same combination. So here is an example of that. So we can form water from hydrogen and oxygen. We can also form hydrogen peroxide whose formula is H2O2 from this same atoms of hydrogen and oxygen. Clear? So what is the meaning of this? That we are saying that two reactants can form react to form two different type of products, or greater than two also. It is possible that number of products can be greater than two from the same two reactants. Okay. Now what is the relation between this reaction and this reaction? So if you see here, the content of hydrogen is same, that is 2 hydrogen, but the ratio of oxygen is changing from 1 to 2. Okay, so here is the ratio is 2 is to 2, or you can say 1 is to 1. That means same amount of hydrogen and oxygen is present. But if we say it for water, this case is not the same. Okay, so therefore if you find the ratio between the oxygen that is used for water and for hydrogen peroxide, then you will find that this ratio is present as small whole numbers. That is, in this case you can see that 16 is to 32, that would give us 1 is to 2. Clear? So what do I mean by this? So if I summarize this thing, so what I am saying that if two reactants can react to form two different products, then the ratio of the reactants will be always in small whole number. So here also hydrogen and hydrogen, that is 2 gram and 2 gram. So 2 is to 2, that would give us 1 is to 1. So here also we got a simple whole number, a ratio of simple whole number. Here also we get a ratio of simple whole number. The statement would be like this: according to this law, if two elements can combine to form more than one compound, the masses of one element that combine with the fixed mass of the other element are in the ratio of small whole number. So we can have example more. We can have one more example. So let us take the reaction of nitrogen and oxygen. Okay. So nitrogen and oxygen can react to give, say, it can react to give NO. Okay. Or it can react to give NO2 also. They can react to give N2O also. Okay. So there are more examples, and N2O5. So we'll not talk about it. Or N2O2. So let us talk about these three. Okay. This is N2O. Yeah. So here you can see very clearly. Okay. So first let us balance this reaction. So we are eager to form the same amount of compound, that is 1 mole of NO, 1 mole of NO2 and 1 mole of N2O. So for that, so let us balance this reaction. So if we take the half of it, again if we take the half of it, right? Now you can see that in these two reactions, this ratio is balanced. Okay, so half and half, right? And the other one is in the, again in the ratio of simple whole number, that is 1 is to 2 is to 1. That would give us 1 is to 1 is to 2, right? Similarly, if you see for these two reactions, and here if we keep the ratio of this, say this and this, both are varying, right? So we can take another example. So let us compare these two, right? This and this. Now in this two reactions, you can see that N2 is varying and half O2 is kept constant. Clear? Again, this ratio for both of this nitrogen will be 1 is to 2. Now if one is not fixed, which is means for this is the case for this one, in which either of them are not fixed, neither nitrogen nor oxygen. Clear? Now if you take again the ratio, that would again give us 1 is to 2 for nitrogen and 2 is to 1 for oxygen. Means the ratio will also always be small whole number. It doesn't matter that one is fixed or not. Now next is Gay-Lussac's law of gaseous volume. What does this law says? So this law says that suppose we are combining two gases to form another molecule. So we can again take the common example of water. So we know that the constituents are hydrogen and oxygen and they both are gaseous in nature. Okay, suppose that we are doing this reaction such that the product that we are getting, that is water, is present in gaseous state, right? Now it is said that according to Gay-Lussac's law, that during a chemical reaction, if two gases are combining to form a product, then they will combine in a simple ratio by volume, right? So here we are taking 100 ml of hydrogen and 50 ml of oxygen to give 100 ml of water. Now in this reaction, you can see that the ratio of the volumes of these two reactants are again in simple whole ratio of simple whole number. So 100 is to 50. Okay, sorry, 100 is to 50. That would give us 2 is to 1. So this is the ratio of whose ratio it is? It is the ratio of hydrogen is to oxygen. That is 2 is to 1. Clear? So this law says that whenever two gases combine to give a product, then they they do so in a simple ratio by volume. So thus the volume of hydrogen and oxygen which combine bear a simple ratio of 2 is to 1. That is 100 is to 50 or 2 is to 1. Next is this, that is the statement. So Gay-Lussac's law of discovery of integer ratio in volume relationship is actually the law of definite proportion by volume. So this is nothing but the law of definite proportion by volume. So initially we saw that the law of definite proportion says that the amount of hydrogen and oxygen that is present in a molecule of water is present in simple whole is constant, right? Now if you compare this definite proportion with Gay-Lussac's law, then it is nothing but laws of definite proportion by volume, because we are saying that ratio is fixed, right? And that ratio we are taking for volume, so it is laws of definite proportion by volume. Now next is Avogadro's law. What is Avogadro's law? So this law is very important for your upcoming chapters also. So what does this law says? So suppose we take equal volumes of two gases. Say we are taking two gases having equal volumes, right? And we are keeping both the gases in at same temperature and same pressure, right? Then what as Avogadro law says, so if we take two same volumes of gases and we keep them in same temperature and same pressure, then the Avogadro law says that it will contain the same number of molecules, right? Now Avogadro made a distinction between atoms and molecules which is quite understandable in present times. So if we consider again the reaction of hydrogen and oxygen, so we are again considering the reaction of hydrogen and oxygen to produce water. We see that two volumes of hydrogen combine with one volume of oxygen to give two volumes of water without leaving any unreacted oxygen. Note that each boxes contain equal number of molecules. If hydrogen and oxygen were considered as diatomic, as recognized now, then the above results are easily understandable. However, Dalton's and others believe in the same time that atoms of the same kind cannot combine. Okay, so it was believed that Atoms of the same type cannot combine, and molecule of oxygen or hydrogen containing two atoms does not even exist. Now, Avogadro's proposal was published in French journal De Physique, and in spite of being correct, it did not gain much support at that time. Now, let us see an illustration of Avogadro's law, right? So, here we are seeing that we are taking one volume of hydrogen and one volume of oxygen, and so we are taking two volumes of hydrogen, right? So if you see here that if both boxes are considered to be kept at same temperature and same pressure, so you will see that there are one, two, three, four, five molecules of hydrogen. Here also one, two, three, four, five molecules of hydrogen. Here also one, two, three, four, five molecules of oxygen. Okay. Therefore, you can see very clearly that if we are taking one volume, then they both are giving same number of, say, molecules. So it is very clearly visible here. Now you will say, sir, here more numbers of molecules are present. So see, we have taken two volumes rather than one volume. Now it will, of course, it will change. So after about 50 years in 1860, the first international conference on chemistry was held in Karlsruhe, Germany, to resolve various ideas. At that meeting, Stanislao Cannizzaro presented a sketch of course of chemical philosophy which emphasized on the importance of Avogadro's work. Clear? So later on, this law gained this recognition. Right? Now, we have what type of laws we have seen. Let us summarize all of those. So first law, what was the first law? The first law was law of conservation of mass. Laws of conservation of mass. So I am defining this whole law in one sentence, that is, matter cannot be created nor be destroyed. Can neither be created nor be destroyed. Clear? During what? During a chemical reaction. Next law was laws of definite proportion. Law of definite proportion. What does this law says? So this law says that in a compound, constituent, the constituent in a given compound, the constituent atoms are present in fixed ratio, means the ratio of the atoms are fixed, right? What does the next law says? It was laws of multiple proportion. Law of multiple proportion. So what does this law says? This law says if react two reactant molecule react, if two reactant molecule react to give two different compound, two different compound, then ratio of reactants in both reactions, ratio of reactants in both reactions, I would say then the ratio of same reactant, right, in both reaction are always of simple whole number. Next, law of Gay-Lussac's law. So that is Gay-Lussac's law. So what was Gay-Lussac's law? Law of So I would write Gay-Lussac's law of gaseous volume. So this reaction was nothing but law of definite proportion by volume. Nothing but law of definite proportion by volume. And the last law says that equal. What was this law? This was given by Avogadro's law. It says that equal volume of gases at a given temperature and pressure. So this is very important to remember that your temperature and pressure should be same at a given temperature and pressure would contain same number of constituent or same number of molecules. Clear? Now this gas can be any gas, so it is true for all gases. Clear? So this was for today's lecture. So with this I end my lecture. Thank you.